Why are roots important in algebra equations? Imagine trying to find the hidden points where a curve touches or crosses the x-axis. Those points are called roots, and they are key to solving many algebra problems. Roots are the values of the variable that make the equation true. In simple terms, they are the solutions that satisfy the equation. For quadratic equations, which are equations where the highest power of the variable is 2, roots tell us exactly where the graph intersects the x-axis. This connection helps us see what the graph looks like and how the equation behaves. Starting with the basics, a root, also called a zero, is a number that, when plugged into the equation, makes the entire expression equal to 0. For example, in the quadratic equation, x2 plus bx plus c is equal to 0. The roots are the values of x that make the equation true. These roots are important because they tell us the solutions to the problem we are trying to solve. In quadratic equations, roots show us where the parabola, the U-shaped graph, crosses the x-axis. If the roots are real and different, the parabola crosses the x-axis at 2 points. If the roots are real and the same, the parabola touches the x-axis at 1 point, called a repeated root. If the roots are complex, meaning they include imaginary numbers, the parabola does not cross the x-axis at all. The discriminant, which is b2 for AC, helps us figure out what kind of roots we have. If the discriminant is positive, we get 2 real roots. If it is 0, there is 1 real root. If it is negative, the roots are complex numbers. Knowing the roots helps us solve equations more easily. They give us the exact values of x that satisfy the equation, which is the main goal in algebra. Roots also help us understand the shape and position of the graph. For example, if we know the roots, we can sketch the parabola quickly and see where it crosses the x-axis. Roots are also useful in real-world situations. For instance, in physics, roots help find the maximum height of a projectile or when an object hits the ground. In economics, roots can tell us break-even points where costs equal revenue. In geometry, roots help find dimensions that satisfy certain conditions. Finally, roots are the foundation for more advanced ideas. They are used in factoring polynomials, solving higher-degree equations, and understanding how functions behave. Without roots, it would be much harder to analyze and solve many algebraic problems. In summary, roots are essential because they give us the solutions to equations and help us visualize and understand the behavior of graphs. They connect the algebraic and graphical worlds, making them a vital part of learning algebra and solving real-life problems.